Okay, next topic in Unit 8. Tell whether the function is exponential or linear. Now we've already gone over how to find linear, okay? This goes 4, 3, 2, 1. So 4 minus 3 is 1, 1, 1. That's always going to be the case. You don't even have to worry about that side because you can count on that. So I've got x, 1, 2, 3, 4. Y is 9, 12, 15, 18. Okay, now here's how to check to see if it's linear. 18 minus 15 is 3. 15 minus 12 is 3. 12 minus 9 is 3. That's linear. Okay. Okay, and then 4, 3, 2, 1, 1, 1, 1. Okay, but look over here. So 128 minus 32 is 96. Okay. 32 minus 8 is not 96, 24. Now here's what you do there. So you know it's not linear. Now instead of subtracting, now you divide. 4. Now divide 32 by 8. 4. 8 divided by 2 is 4. Now it's exponential. Okay. And the reason why it's exponential because you're always timesing by a number, because 2 times 4 is 8, 8 times 4 is 32, 32 times 4 is 128. But you find the factor by dividing, okay? Exponential. Okay, next one, xy, x 1, 2, 3, 4. So that side's the x side you don't even really worry about. Y, 40, 50, 45, 40, 35. So again, 35 minus 40. Negative 5. 40 minus 45, negative 5. 45 minus 50, negative 5. Makes sense, you're subtracting 5 every time, okay? So that is linear. Now next one, 1, 2, 3, 4, and then 64, 32, 16, 8. So take 8 minus 16, you get negative 8. 16 minus 32 is not negative 8, so we know it's not linear. Now see if it's exponential. I still want you doing the pattern, okay? Now instead of subtracting, you're going to divide. 8 divided by 16, 0.5. 16 divided by 32, 0.5. 64 or 32 divided by 64. So it forms a pattern, just not a linear pattern. It's called an exponential pattern. Linear is when you add by the same amount every time. Exponential is when you are multiplying or dividing by the same amount every time. Okay, but you find the factor by dividing. So subtraction doesn't give you your pattern, then you go back and divide. And if it's the same thing, it's exponential. Now the next thing. Now instead of looking at a table, you're looking at an equation. You need to tell whether the function is linear or exponential. It's very easy to tell. Put your operators into the problem. Y equals 4 times 5 to the x power. So 4 and 5 is times. 5 and x is a power. Put an upside down v. It's called the caret symbol. Okay? If the x has a caret symbol with it, it's exponential. Okay. Next one, y equals 12 times x. So 12 and x is a times. If the x has just a times dot with it, with the operation, with the number in front of it, a times dot, then it's linear. Because there's no exponential function. Next one, y equals 5 times 0.25 to the x power. Well, since the x is an exponent, that's exponential. Okay, and then the last one, y equals 7x plus 3. So 7 and x is times, x and 3 is plus. So it's just a times with the x, with the number in front of it, so it's linear. Boom. Okay. Now, in the next problem, they're all exponential functions. The directions are tell whether the function represents exponential growth or decay. Okay? Exponential growth or decay. Here's how we're going to do this. Okay? Y equals 0.93 times 2, put a caret symbol to the x power. And I just want you to make a table and go 0, 1, 2. Now, just plug those into a calculator. 0.93 times 2, raise it to the power of 0, because x will be 0. You just replace the x with 0, and you get 0.93. And that makes sense, because 2 to the 0 is 1, and then 0.93 times 1 is 0.93. Now take 0.93 times 2, hit your caret symbol, 1, 1.86. Now put 2 in for x. 0.93 times 2, caret 2. What's happening here, is it going up or going down? It's going up, so it's growth. Okay, next problem. Y equals 2 times 0.68 to the power of x. Okay. 0, 1, 2. I'm going to do a table. Then I'm going to tell you how to do it without the table. But if this other way doesn't make sense, use the table. So put 2 in. So y equals 2 times 0.68 to the power of 0. So if x is 0, y is 2. Because that to the 0 power is 1. Anything to 0 power is 1. And then 2 times 1 gives me a product of 2. 2 times 0.68 to the power of 1, 1.36. And then 2 times 0.68 to the power of 2, 0.9248. Now that's decay. It's going down. Now some of you might be wondering, why is that growth and that's decay? Well, I'm going to tell you why. But if you don't understand this next thing, you need to be using the table. Y equals 6.8 times 0.2 to the power of x. Circle the base of the power, okay? That number there, is that less than 1 whole or bigger than 1 whole? Okay? 0.2, is it less than 1 whole or bigger than 1 whole? It's less than 1, okay? If it's less than 1, it's going to be decay. When you multiply a beginning amount by a factor less than 1, that number there, it's decay. It's going to start at 68, just like that started at 2, and then it's going to decay. Because right there, you're taking the 2 times a factor repeatedly that's less than 1. Okay, y equals 50 times 1.03 to the x power. Okay, now make your caret symbol and circle that part. So 50 is your beginning amount. Now you're timesing by a factor that's greater than 1. If you times by a factor greater than 1, it's growth. See, up here was growth because I took that, I times it by 2. 2 is greater than 1. Okay. So you can either do the table or do the less than 1 greater than 1, but it's on that number right there. It's whatever the base is to the x.